Здравствуйте, меня зовут Колокольцев Александр, я работаю в компании Positive.
Hi, I'm Alexander Kolokoltsev. I work for Positive Tech. We'll discuss today detection or identification of automatically generated domain names. Now we'll first discuss DGA, and I'll explain why we need to distinguish, to identify those DGA names. These are the algos that help generate lots of pseudo-random domain names that are often later used by the perps as a kind of a communication channel. Well, the way it starts is that the perp and the infected host have a seed that they share that actually helps them come up with identical tables of pseudo-random names if in the future a perp registers a name like that. The infected host, by making a recursive calls to the DNS server, will be able to get in touch with the perp. Well, that way, the perp has a pretty well hidden communication channel. However, if we have a DJ discovery algo, we get an upper hand. We decided to use the n-gram method in order to attack this problem. Let me quickly explain what n-gram is. N-gram is a key phenomenon here. So by n-gram, or we'll refer to n-grams in this presentation, and by n-gram we'll refer to a sequence of symbols of particular length. You'll see here two different domains. One is legit, the other is not. So you see here 4 character long n-grams, and this particular length is not a coincidence. Our analysis has shown that this is the kind of length that gives you the highest precision. We will identify 3 types of n-grams. Some are legit, they are only used in legit domains. Others are malicious, you only see them in DJ domains. And finally, we have neutral ones, that is, they can be malicious or legit. In order to test this analyzer, we took legit domains from alexa.com. Well, malicious ones came from Babenic Consulting. Let's look at the analyzer itself now, and the way it works. So we have a multitude of domains. We will have a kind of a population sampling and a test sampling. One we need to sort of populate the system with. And we need the test sampling to see whether the system actually works well or not. Well, first thing we gotta do is teach the algo. We take our first sample, we break it into n-grams, and then we assign different weights to them. For legit ones, the weight will be 1, it will be -1 for malicious, and for neutral ones, we'll select a value between -1 and 1. A particular value will be driven by the results of the evolutionary learning algo. So in the end, we get a model that has pairs of n-grams and their weights. This is the model as trained. And now we can use, for example, the CryptoLocker domains to test it. You'll see that here we broke this domain into n-grams, and then the system searches. So the system searches for all these individual n-grams, calculates weights for them all, comes up with a total weight. Now, if the total weight is below a particular threshold value you can set, and I'll cover that in more detail later, then this domain will be announced as a DGA domain, otherwise we'll consider it legit. Well, sometimes the model will fail to find all the n-grams for a particular domain. In this case, it gets a weight of 0. Well, in this case, it can easily happen that we won't have enough information to decree a particular domain, a DGA or a legit one. So in order to avoid this problem in the testing stage, we had to come up with a routine. So we decided that every domain in the test sampling actually had some sort of correlations, overlaps with the training sampling. Now, in other words, we wanted a number of n-grams to be present in both the testing sample and the training sample. And we hope that that way we would be able to verify whether a particular domain falls into this or that category. Let me show you now the test results. Alexa and Bambini Consulting gave me this result. So over 2 million domains in total. Shown here is actually the threshold value I mentioned previously. So we tested a number of thresholds. Minus 1.5 turned out to be the best threshold. It actually optimized false positive and false negative ratios, so to speak. And shown here is the comparison. Now, the difference between the two curves shows the benefit we got from slightly manipulating the samplings rather than going for a totally random sampling. We believe that currently the precision of this method gives you, stands at around 98-99%. That's it. Thank you very much. Hi, Artem Himichin from Kaspersky Labs. Why did you go for 4-letter n-grams? And how did you get domains from Alexa? Did you just take everything they had? What about transliteration? Well, there could be, for example, alleged domains that could be made of suspicious n-grams for an English person, but that could be simple transcriptions of Russian words. Well, n-gram size, just like the threshold value, is the result of our experiments. We experimented with 3, 4, and 5-letter n-grams. Stuff that's smaller, just like stuff that's longer, doesn't yield enough information. We focus on 4-letter n-grams because that way we achieve the highest precision in our classification. We didn't take all the domains from Alexa. We only studied the domains that have a length over 6 letters, because for shorter domains we won't be able to properly classify the stuff, because you can't fit more than 1.5 n-grams there. And we did take a number of transliterated names as domains because the number is actually quite significant. It did impact negatively our precision, but not by much. And as regards the international domains, we've only been analyzing the Latin named international domains, but you can easily add to this methodology a Russian language module, and then you will be able to recognize Russian language domains as well. Have you compared your method to simpler methods where you would simply do frequency analysis on consonants versus vowels, or frequency of use of individual letters? Because randomly generated names usually fail the consonant vowel test. Well, very often DGA names are collections of words, not collections of letters. So that way you will maintain the usual ratio between consonants and vowels, so frequency analysis won't help you. However, if you apply some additional linguistic logic to it, you will be able to discover DJs, because they often combine words that don't combine in regular language. How many n-grams did you come up with? Slightly more than 1 million. Well, if we increase the number of domains, the number of n-grams will also increase, I think. Thank you.